Hello, my name is Macy, and today I'll be discussing how physics content is relevant to the sport of volleyball. The motivation behind this project was my love of volleyball. In high school, I played for 2 years. I play in an IM volleyball team at MSU, and this semester my team made it to the 4th round of playoffs. Overall, I am fascinated with how physics plays a role in volleyball because forces are constantly at play throughout a game. There are so many different motions that require different amounts of force. However, today we'll be focusing on 3 main actions: bumping or passing the ball, setting the ball, and spiking the ball. In class, we discussed Newton's second law, which states that the acceleration of an object is dependent upon 2 variables, the net force acting on the object and its mass. In fact, the well-known equation we will be using today is force equals mass times acceleration. A force is a vector that quantifies the interactions between 2 objects, while a net force is the sum of all forces acting on a system. In this case, we are discussing the net force between a player's hand and the ball. It's important to note that if the volleyball was not moving or changing velocity, its net force would be 0. Additionally, in our systems, the mass is constant while the acceleration and direction of the ball are constantly changing. As for the system schema, there is the volleyball player and the ground. There's a contact force between the volleyball and player, a gravitational force between the volleyball and ground, and both contact and gravitational forces are present between the player and the ground. And finally, in the free body diagram, there are 3 main forces that act on the volleyball. There's a gravitational force, which is the ground acting on the volleyball, the applied force when the player is in contact with the volleyball and applies force, causing the ball to spin and move in some direction, and there's a frictional force due to air resistance. However, we will not be focusing on frictional force today. The mass of the volleyball was 275 kilograms, while the circumference was about 66 centimeters. However, in an actual indoor volleyball game, the circumference is between 65 to 67 centimeters, and the weight of the ball must be between 260 and 280 kilograms. Furthermore, although we discussed all the different forces that act on the volleyball, we'll be focusing on the applied force between the player and the ball. After retrieving data from Tracker, we found the acceleration of the ball at the point of contact between the hand and the ball. Then, to calculate the force applied, we used Newton's second law and give an equation, force equals mass times acceleration. This is a video of me bumping the ball. Before getting into the 3 motions, it's important to note that the initial height was calibrated at my height, which is 5 feet tall, and 1.524 meters tall. Additionally, for each motion, I threw the volleyball up in the air as if someone had passed me the ball. Also, from discussion in class, we know the acceleration versus time graph also depicts the force versus time graph. When bumping the ball, the acceleration at point of contact was 132.2 meters per second squared, and the force was 36.35 newtons. Through the line of best fit, you can also see the velocity versus time graph is a decreasing slope, while the acceleration versus time graph is constant. This is a video of me setting the ball. When setting the ball, the acceleration at point of contact was 110.1 meters per second squared, and the force was 30.27 newtons. The velocity versus time graph and acceleration versus time graph is very similar to the bumping motion graphs. However, the initial velocity is smaller than the bumping motion, while the acceleration is more negative. This is a video of me spiking the ball. However, it's important to note that the video was taken as a wall spike and not in mid-air. When spiking the ball, the acceleration at point of contact was negative 43.70 meters per second squared, and the force was negative 12.017 newtons. These graphs are very similar to the other motion graphs. However, it's important to recognize the ball's initial speed was slower when spiking the ball, as opposed to bumping or setting. As for the acceleration graph, the ball's acceleration was much more negative than the other motions. Additionally, there appears to be a greater increasing slope in the acceleration versus time graph. Overall, I found that bumping the ball resulted in the highest force of contact, setting the ball had the second highest force of contact, and spiking the ball had the most negative acceleration, and therefore the lowest force. This is because when spiking the ball, the control over the ball is much lower as opposed to bumping or setting. When bumping and setting the ball, you are able to use both hands, which increases one's control. However, when spiking the ball, you are only able to use one hand. Due to this lack of control, the force of contact between the player's hand and the ball should not be too large. There are many ways players can manipulate physics throughout a game of volleyball. In this case, players can manipulate the direction and speed of the ball by increasing or decreasing the force of contact. By increasing or decreasing the force, this in turn increases or decreases the speed at which the ball moves, the direction, and the overall quality of defense. For example, if the force of contact on the ball is increased, the speed of the ball after contact will also increase. However, with increased speed comes decreased control. Above all, factors that affect the force of contact include placement of the hand on the ball and the angle, the speed at which the ball is going toward a player, the mass and acceleration of the ball, and one's form. As for factors that may have affected the trials, there was an inaccurate starting height, calibrated at 1.524 meters, inaccurate tracking of the ball through tracker, the speed at which the ball was falling toward me, and a possible draft due to the air in the building. However, this factor was neglected. Overall, through understanding all the different forces, the amount of force necessary for each volleyball motion, and the key factors that affect a play, we are able to understand a little more how physics is relevant to the sport of volleyball.